So what we see here is DSCP values. With this value, we mark traffic and we say how much we prefer the traffic. But what is the meaning of this value? Say, for example, what does it mean AF32? AF stands for assured forwarding. EF stands for expedited forwarding. Now, what is this AF32? How they got this 32? I told you for DSCP, there are 6 bits. That 6-bit is divided into 3 sections. The 6-bit is divided into 3 sections. This last bit, and this 2-bit, and then the 3-bit. This last bit is always 0. Now, if all are 0, there is no QoS. Correct. So, when there is 1 here, that will be called as AF10, which is not listed here. It's not in class 1. Class 1 starts from AF11. What does it mean? 1 here and 1 here. You need to calculate separately. This is 1 and this is 1. You see? AF11. This bit will be always 0 and will never be calculated. Never be considered to calculate. Now let's see this one. This is AF32. How you got AF32? 0, 3 means 2 plus 1, 3. And then 32, 2 means 1, 0. Is this matching? Yeah, 3, 0. And 2, 0 at last. 1, 0 in the beginning. You see? This is how we should read. So if someone says AF43, how do you write in binary? Can anyone direct me? Tell me what I should write. AF43. How should I write? 6-bit I said, no? 6-bit. Tell me. 43.
1, 0.
1, 0.
1.
No. 4. This is 4. And this is 3. And this is 0. See? 2 to the power of 2 is 2. 2 to the power of 1 is 1. So totally 3. 2 to the power of 3 is... What am I writing? Sorry. 2 to the power of 0. 2 to the power of 1. Okay. 2 to the power of 1 is 2. 2 to the power of 0 is... So this is 2 to the power of 2. 2 to the power of 2 is 4. 4 plus 0 is 0. 43. Am I right? You see? 43 to 1, 100. Correct, no? Please ask me a question if you have doubt.
So each of these segregated parts is where you sort of apply the binary conversion.
Yeah. See, I'm trying to explain you how you got this number. If 11, you should not write, okay, 11 in binary. How you write 11 in binary? Say I have 6 bits. No, I told you 6 bits. Why did someone is typing? At least mute and type, please. Whoever is typing. Now, because I'm wearing my headset, it's very difficult for me. Please see AF11. I said 6 bit. If you don't know how you got this, what you will write is you will start writing 11 here. 11 means 8 plus 3. But this is not the right answer. AF11, you see, it's totally different from what you see here. It's different. So what I'm coming to say is last bit don't consider, make it as 0. So here we are seeing how to understand this. AF32, AF33, AF43. All that you need to do is in that 6 bit last bit, you should not make it as 1 at any point of time. It should be always 0, should be remaining 0. And then 3 bit separate, I wrote a 3 bit separate, 2 bit separate. Calculate separately, then you will get the answer. Okay, please ask me question. Check whether what you understood is matching. Do this one and see by your own. AF33, how it will look like in binary. Do it by your own and check whether it is matching with this one. Do it now. Fine. So it is not very difficult. So if only class 3 packets are coming, in that class 3, some packets have to be dropped, need to be dropped in order to save the other packet. Now, which class 3 packet to drop? The router will drop those packets that are coming with AF33. Yeah, it'll keep dropping AF33 packets until it reaches the limit, until the congestion is avoided. Congestion is reduced. Until the traffic jam is reduced, it will stop all those traffics that are coming with AF33. It will stop dropping. Even then, if there is too much of congestion, it will stop dropping 32. So in short, what I want to say is this AF31 will never get dropped. And the packet with AF31 is highly prioritized than AF33. But is AF31 high priority or AF23 high priority? Highly prioritized, which one?
31.
Okay.
31 is high priority.
Very good. Now, this is the question. There are packets coming with AF23 and 13 and 31. There is congestion, too much of congestion. Which one will it drop? Will it drop 31 or 23 or 13? Which one will it drop?
13.
Very correct. Because it is class 1. First of all, it will see whether there is a class 1. If it is class 1, then that class 1 will be dropped first. And then if still the congestion is continuing, it will drop class 2. This is how it works. So in another simple way, if I need to say, if it is within this will be dropped first. If it is between this will be dropped first. Did you understand?
Yes.
Why only Rajshekhar is responding? What happened to others?
Yes, understood. So the
Yes,
only
sir.
thing is in the horizontal class 3,
Mhm.
if there is congestion, you're saying 33 will get dropped.
Yes. That is the high probability of dropping.
Okay. But if you look across the class, then the lower class gets dropped.
Yes.
So
Vertically,
even
it is the lower one. Horizontally, it's the high one.
Okay.
Now let us see the picture which was taken from Google. And you see, high drop preference. Okay, let me put it in a nice way here. Same picture. I don't want the scribblings in it. Now you see, high drop preference. They have showed you only this horizontal view. High drop, low drop, medium drop. So when congestion happens, this one will be dropped first. For class 4, this one will be dropped first. So we have 4 classes. If it is vertical, this will be dropped first, and then this, and then this, and then only this. Because class 4 is highly prioritized if you come in vertical. Means if you compare between the classes, bigger the class, high the priority. If you are comparing within a class, higher the number, more possibility of drop. And if a packet has got EF means, you know what, 53 is what EF. This is EF 53. See, 5 plus 3, 53. This will be the highest priority packet. I told you in IP precedence, there's only 3 bit. With a 3 bit, you will have 000, 001, 010, 011, 100, 101. Now, 5 is getting matched with 53, EF 53. If it is IP precedence, you will not be using 6 bit, you'll be using 3 bit, and all those packet that is marked with 5 is equal to 53 in DSCP. It is equal to 53 in DSCP, 53. You no need to map actually. If you say I trust IP precedence, automatically it will get mapped to DSCP 53. That's why they have written 5 right straight to EF. 4 is getting mapped with all this 4. In class 4 we have 3 4s. That's it. Please ask me any question if you have.
So I don't understand the 6-bit, the last 3-bit.
I don't understand your question now.
You asked me. You asked a question for FA33 before. And
Okay, AF33.
how do we convert this in binary?
Look at this. If you have AF33, take these two numbers separately. This 3, you use 3 bits to write. This 3, you use 2 bits to write. And the last 6th bit is always 0. So how do you write 3 with 2 bits? 1, 0. How do you write 3 with 3 bits? 0, 1, 0. Now you compare here. 0. Wait a minute. 33, no? Okay, this is 3. 3 means what? 2 plus 1, 3. Okay, now you compare 0. Where are we? Wait. Am I doing? I think I'm saying something. I'm writing something. I'm writing 2 only. You're also quiet. That's why mistake. This is 3 and this is 3. Yes or no? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. 1, 2,
Yes.
4. This is 3. This is also 3. That's how you got this. 0, 1, 1. Another 1, 1, 0. You understood this part now?
Yes, sir.
All right.
Yes, sir.
Anything? Anyone else have got any question?
So in last class, we discussed about the layer 2 marking and layer 3 marking. So DSCP is layer 2 and
No. COS is layer 2.
okay.
COS is found in IEEE 802.1.1q.1p headers, means the trunk headers. In layer 2 header, when you do trunking, you will see in .1q header 3 bits. Now, if a packet is coming from a switch to a router, and in the router also, if you want to use only 3 bits, then you will go with IP precedence. So here also you have 5 classes, 0, 1, 2, 3, 4, 5. And 6 and 7 is for the management, I told you, reserve. Likewise, here also 0, 1, 2, 3, 4, 5. And 6 and 7 is management. So whatever you prefer, whatever the level of preference you give in layer 2 is also the same level in layer 3. Because the same number of bits, but the packet that is carrying this is not same. Packet is same, the layer is not same. This is carried by layer 2 header. This is carried by layer 3 header. So even though in layer 3 you have 6 bits, this 3 you totally ignore if you enable IP precedence on the router. On the same router, instead of IP precedence, if you will enable DSCP, you are now adding additionally 3 more bits so that you will have more options. You see here you have only 5 options, 5 levels of priority. But here you got more options. more matches, more granular. In class 5 you have one mapping. In class 4 in IP precedence in COS there is only one priority. But here you have 3 levels of priority in class 4. 3 levels of priority. So in each level, in each class you have 3 levels. If you take one COS packet, in DSCP it can be further divided into 3 different classes. Low drop preference, medium drop preference, high drop preference. So more granular is DSCP. So both DSCP and IP precedence are layer 3. Whether you use DSCP or not, layer 3 packets are going to, layer 3 header of the packet is going to always have that 6-bit. When you say I want to use IP precedence, it will focus only 3-bit. Okay, now what let us discuss like this. I have a router here, which is only IP precedence. No, let me put it in the opposite way. I have a router which is DSCP. So I'm matching some packet and then let's say I'm matching telnet packet, and then I'm giving 43, and I'm matching FTP packet, and I'm mapping to 41. Actually, it should be opposite. Telnet is high priority than FTP. Okay, because telnet is management. FTP can be recovered. Telnet, if you drop, it will close the session.
I have a question.
Yep.
So when your traffic enters your network, like from a layer 2 switch, it goes up to the layer 3 and goes up to the layer 3. You mark your traffic, you do COS on the layer 2 switch on the frame. When the frame goes all the way to the router, do you have to like remark it?
That is what I am trying to say.
Okay.
If you don't mark, if you simply say I trust COS, then what happens? The COS 3 is getting mapped automatically to IP precedence 3.
Right. Okay.
Or if I don't run IP precedence, if I am running DSCP, the COS 4 is getting mapped to DSCP 43. DSCP 43. And then if you say no, if it is a FTP packet, sorry, if it is a telnet packet, I want it to be 41. All the rest can be 43. So excluding telnet, see both here, telnet and FTP is 4. But when it comes to the router, you write an access list and say all those packet that is coming with COS 4, and if it is a telnet packet, it should be marked with DSCP 41. You're manually doing it because by default it will go to 43. And all the rest can be default, which means the FTP will be 43. Now, telnet is high prioritized by this router compared to FTP. If there is need to drop because of congestion, it's going to drop only FTP, not the telnet. And when this router send this traffic to another router, let's say there is only IP precedence you configured. Now both are going to be mapped with IP precedence 4. Automatic, you don't need to map it. Automatic. Anything that's coming with 41, 42, 43, it's going to be mapped to 4 of IP precedence. If it is going to layer 2 switch, in the layer 2 switch, if you say I trust IP precedence, then from IP precedence 4, it will be mapped to COS 4. That's the power of the word trust. The mapping is automatic, right? So try to keep the default mapping. But if you want to have different type of mapping, a weird mapping, what type of weird mapping is that? If it is telnet 4, I want to map it to 5.1, which is not actually default. You can do it. That's customized mapping. Some iOS supports this customized mapping, high-end devices. But recommended to keep the default. Default is very decent.
And to keep QoS enabled throughout your network, so basically you have to do this classification on every device based on whatever layer it operates on. So if it's a switch, you have to
Yes.
mark your traffic on COS. If it is a layer 3 device, then it is DHCP or IP precedence.
Yes, that is why it is called as what? Per hop behavior. That is why it is called as what? Differentiated service. Every router, you can have different services. Differentiated service. It need not to be same, but it is a practice to keep it same. The difference between integrated service and differentiated services, even though in differentiated service you try to keep the same end to end, there is no reservation end to end. When the packet goes, every hop decides how to treat it. But if you are going with RSVP protocol, which is there in service provider track in layer 3 traffic engineering, there is a protocol called reservation protocol. When you enable RSVP, this resource reservation protocol RSVP will block the bandwidth end to end, P to P, so that no one will be able to use the bandwidth till the traffic pass through the service provider network. So in-serve is not actually appreciated, only for very costly customer. Not every ISP is ready to do that. Some ISPs are providing this in-serve, but actually there is no big difference. People market it and some people buy it. Even diff-serve can also provide the same output. Any other question? Now let us see one example. You see I have two routers here. In this example, what we are going to do is we are going to match the ICMP traffic, which is generated from router 1, and we are doing policing. What is policing? What is shaping? Policing is looking for the amount of traffic that is entering the router or a switch. If the amount of the traffic exceeds the level that they're supposed to send or received, if the level is if the amount of packet exceeds the level of bandwidth that it's supposed to come, if it is going beyond the level, it will drop. it will drop those excess packets. That is called policing. Shaping is you take those excess traffic and put it in a low priority queue so that it will wait in that queue and get served later. That is shaping. Usually, the customers will do shaping before sending the traffic to provider, because they don't want their packet to get dropped on the provider side, because provider is doing policing. Provider don't care. If you send the traffic within the limit, then the traffic will go through. Otherwise, it will get dropped, because providers are business people. You need to send within that limit. It's not like someone was telling me in few batches earlier, many years back when I was teaching. Sir, you know what I did? I'm a very genius guy. I used a special software in my router, and then I send my traffic. I'm supposed to send only 100 meg, but I can send 150 meg. Actually, he don't know that 50 meg he is sending extra is getting dropped in the provider edge. As a result, the packets are getting retransmitted again and again. For that 50 meg, the packet needs to be retransmitted, the TCP sessions. So what will happen is there will be there is going to be a big delay. There's going to be a big delay because the packet is simply going to the provider. Provider is dropping that 50 excess, and when he drops, the TCP will keep resending it. So he was saying that, sir, I am able to send 150 meg when I have subscribed only for 100 meg. That is actually not true. He may send 150, but policing is going to happen on the provider side. So to avoid unnecessary resending TCP packets, what needs to be done is, while sending itself, you do shaping. From your office, before the traffic goes out on the edge router towards the WAN, before it goes to the service provider, you set a rate limit. You set saying, okay, 100 meg. If it is more than that, you put it in a low priority queue so that it won't go there and get dropped. You are slowing down the sending packet so that it won't go there and get dropped. So customer will always do shaping. Don't forget. The provider will always do policing. Yep. Now next. Single rate two color policing. Configuration is done using MQC. What is MQC? Modular Quality of Service Command Line Interface, in which we first define class map. In class map, we'll match this ICMP access list traffic using access list. We'll match the ICMP traffic. After classification, we'll call the class inside a policy map and we'll set the rate limit. Let's see how to do that. You see. Okay, I was telling you will write an access list and call the access list. That is one way. You can also straight away match all ICMP traffic. See, you need to understand one thing very well. What is that? Matching ICMP protocol is matching for all source and all destination. If you want to match any ICMP, then you can do this. But if you are matching ICMP for the traffic coming from one particular IP going to another particular IP, you need to write an access list and then call the access list. Here they're doing simple example. They don't want to make things complicated. So they simply match all ICMP packet, all ICMP protocol packets in the class map. And then they do N bar. N bar stands for network based access. It's like, setting a limit. Wait, N bar network. So network based application recognition, that's the meaning of N bar. Here simply, the application is ICMP application. All the application that uses ICMP protocol. So we already created a class map. So we go under the policy map, give any name that you like. It can be same name that you used in the class map. It can be same name also. And then you go inside the policy map and you call the class which is created earlier. And here they are setting limit like 128 meg, 128 meg for ICMP. That's the police. If the traffic is within that limit, transmit. If it is within the limit, what is the action? Transmit. If it exceeds the limit, drop. Who will do this? Provider. ISPs. Okay, ISPs are going to do policing. See, 128 KB, not meg, 128K. Okay, this is in bits. This is in bits. So when you're doing kilobits, all right. So you can also write this 3 line in a single line also. Police this much, confirm action, transmit, exceed, extend. You can also write in a 3-step or one single line. All right. At last, you need to apply this to an interface. You see, you go under the interface and you call the policy map by using the keyword service policy. As the traffic enters R2, you are going to take action. Who is R2? R2 is ISP. That's all, right? And now when you ping, see they're pinging continuously many ICMP packet. So you will find some drops here and there because it is going beyond that 128 kilobits. Whenever it goes beyond 128 kilobits, there will be a drop. This I'm going to do and show you. It won't take much time, okay? I'll quickly show you and then I'll type the show command and show you. All right, let's do this. On router 2, F00 will be 23.2 and the other interface is G3/0. 1012. This goes on router 2. Oh, I made a mistake from the beginning. I need to correct now in other 2 routers. Yeah. Okay, now I should see some reachability between R1 and R3. I'm waiting for OSPF to converge. Once the OSPF converges, the ping should happen. Show IP interface brief. Is the interface is up? G3/0 is up. And F00 is also up. Good. And do I have two neighbors in R2? Show IP OSPF neighbor. Wonderful. So I think the ping should have finished. No, still not. Okay, now only the convergence is happening slowly. Okay, it's pinging. So we got the OSPF, we got the reachability, but there is no QoS. On R3, I'm going to enable telnet. Line VTY 04. Login. Local. Username 123. Password. Enable. We got the telnet also ready. We can test it now by telnetting from R1. So we are able to telnet. Now let's write some QoS on R2. We want to prioritize telnet packet and we want to give less priority to ICMP. So we are not marking with the DSCP or IP precedence or COS because R1 is not sending any packet with any marking. If you want to do that, you can also send. Okay, let me do one thing. On R1, I'm going to mark. Okay. Class map. Telnet. Match IP protocol. Match IP protocol. Match IP. No. Match protocol. TCP. Okay. Telnet. And then I'll write another class map. Class map ICMP. Match protocol ICMP. Now I have two class maps, see do show run or do show class map. There are two class maps, one is telnet and one is ICMP. And then I'm going to say policy map. I'll say policy 1 class telnet, and we are going to mark with DSCP IP DSCP set IP DSCP. You see AF, I'm going to say AF. This is telnet, right? So I'm going to give high priority AF43. So a queue with high priority is going to get created And in that queue, this telnet traffic will be placed. Yep. So, sorry. If. And then in the same policy map, I'm going to call the class ICMP set IP DSCP AF maybe 13 DSCP. Done. So the policy map need to be applied so that the marking will be done before sending the packet out. So I go under interface G3/0 service policy output. See, while sending out pol 1. That's the name of my policy. You see, show policy map interface G3/0. It has got a class map. Policy map has got a class map called telnet. If that is matched, it is going to mark it with this. So far, no packet has been marked. If a packet is matched with ICMP, it is going to mark it with this. So far, no packet has been marked. For the rest of the traffic, it is simply sending without doing any marking. Now let us do telnet. I need to bring this under the recording area. This, okay, now it is in the recording area. Telnet 3.3.3.3 source interface loopback 0 and username password done. Likewise, we'll also do pinging. Ping 3.3.3.3 with the source 1.1.1. Repeat 10 times. Now let us verify. Show policy map interface. Look at this. 39 packet of telnet has been marked with this and sent. 10 packet of ICMP because I pinged only 10 packets marked with this. You understood? Now marking is done by this router. I can now match that in R2. I can write a class map. I'll say for telnet match IP DSCP. I think I gave 43. Class ICMP match IP DSCP. Did I give 13? I believe 13. Let me check. Yeah, AF13 and AF43. So I'm matching 13. Let me verify show class map. DSCP 13. I think I should not say like this. I should say AF13. That's the right way. Match IP DSCP AF13. Yes, that is what we marked there. Class map telnet match IP DSCP AF43. No space. Now I have to go to policy map Hold one. Class tell. If this match happens, what should I do? This is what telnet traffic. You have a lot of options to do. You can shape the traffic. You can police the traffic. You can also set more priority. It's already prioritized. The old technology like fair queues you can put. So I'm going to shape the traffic. Shape. This feckin and beckon is for the frame relay. It's not for us. Enable the traffic shaping to beckon. Beacon is, signaling if there is too much. I can say average, so that I can say the committed information rate. So I can say average percentage, 5% of the bandwidth. Telnet can use. That's actually more than enough. Next, class map. What's the other class map name I gave? ICMP. Then I'm going to say police bits per second. 15,000 means 15 KB. If it is within the limit means confirm action. I want to transmit. I do not want to see. If you want to change the DSCP value, you can remark it. But I don't want to remark it. I want to simply transmit. If it exceeds, this is also shaping. I can remark it so that it will go to another queue. I can give another DSCP value. This is also one way of shaping using the policing command. So exit action, I simply want to drop. And now I'm going to apply this to the interface. Now I can apply this as the traffic enters in as a service provider. I can apply it as the traffic enters in. Here itself I'll drop so that it won't get congested here. So I'll go to router 2, interface G3/0, service policy name is pol1, input, service policy input pol1, boom. Our traffic shaping feature is not supported in the input policy. This version don't support traffic shaping, but policing it is going to support. Let us verify what it shows. Show policy map interface G3/0. Oh, sorry, it didn't take. So no problem. I'm going to now for telnet also I'm going to do policing so that this command will be accepted. Policy map telnet, and for this also I'm going to do policing instead of shaping. If I say output, if I apply it on F00, this will be accepted, but I want to do it input because output outside we did here. I'm doing inside here. Okay, now here I'm inside this. I need to say policing. You can also say the committed information rate. If the provider provides you like 100 meg, they will set committed information rate 100 rate, specific rate. Let me go with the simple one, bits per second only now. 25000. Exceed action. Sorry, confirm action, permit, transmit. Exceed action, drop. All right. Now let us go and apply this into interface G3/0 service policy input pole 1. Let's verify show interface policy map, show interface, show policy map interface G3/0. You can see here so far no packet is dropped. And for telnet, this is the rate limit, committed information rate. For the ICMP, this is the committed information rate. So far, no packet transmitted or exceeded, nothing, no action drop or transmitters done. For those traffic that is not matched, it will match with this default class. I did not create the default class, it will be there. Now I'm going to go to R1 to do the test again. I'm going to now ping repeat another big number. Okay, see, there is a dropping. One packet dropped. Why? The middle router is dropping. 2, 3. So let's go now to R2 and verify. It should show some drop packet for ICMP. You see, ICMP so far, this many packets and this many bytes, and 8 packet has exceeded. As a result, they are dropped. So 912 bytes have been dropped. Transmitted is 23,000 bytes. Now, by this time, it should be more. 50,000 bytes transmitted. Yep. So this is what QoS is. All right. So like this, you can have multiple different protocols, different mappings, matching, COS, IP precedence, same command only. Where I did DSCP value, you put IP precedence. Set IP precedence instead of set DSCP. Try this something of your own, keeping this as a model. Any question? Right. If no questions,